Have you heard of the Oort cloud? It sounds like something out of science fiction, a swirling veil of icy fragments drifting at the edge of everything we know. But it's not fiction. It's one of the most mysterious and distant parts of our solar system. And today we're going to journey there, billions of kilometers from the sun, to uncover the secrets of this cosmic frontier. Let's start with a sense of scale. You know Pluto, right? It's the tiny, icy world that once held the title of ninth planet. Well, the Oort cloud begins at least 2,000 times farther from the sun than Earth is. That's 2,000 AU, or astronomical units. And it doesn't stop there. It may stretch all the way out to 100,000 astronomical units. That's nearly a quarter of the distance to the nearest star, Proxima Centauri. It's not a flat disk like the asteroid belt or the Kuiper belt. No, the Oort cloud is thought to be a spherical shell of icy bodies that surrounds the entire solar system, like a giant cosmic snow globe. But here's the twist: we've never actually seen it. So how do we know it's there? That's where the story really begins. Chapter 1. A theory born from comets. In the mid-20th century, a brilliant Dutch astronomer named Jan Oort was trying to solve a mystery. Where do long-period comets come from? Unlike short-period comets, which circle the sun every few decades and originate from the Kuiper belt, long-period comets appear unexpectedly. Their orbits can stretch tens of thousands of years. Some swing in from all directions, not just from the plane of the solar system, and many of them never come back. Jan Oort noticed something curious. These comets seemed to come from very far away, much farther than anything we had mapped. So he proposed the existence of a distant icy reservoir, a kind of comet nursery surrounding the sun, a place where countless frozen objects waited, undisturbed, for eons until something knocked them inward and turned them into the bright comets we see in the sky. This idea became known as the Oort cloud. Chapter 2. What's it made of? The Oort cloud is thought to be home to trillions of icy objects, some as small as pebbles, others dozens of kilometers across. They're made of rock, dust, and frozen gases like water, ammonia, and methane. In fact, these are some of the oldest building blocks of the solar system, leftovers from the time when the planets were forming over 4.6 billion years ago. Back then, the solar system was a chaotic place. Newborn planets were carving out their orbits, and many icy planetesimals, tiny early building blocks, were being flung outwards by the gravitational forces of massive planets like Jupiter and Saturn. Most of these ejected objects ended up in interstellar space, but some slowed down just enough to remain gravitationally bound to the sun. They didn't fall back in. They didn't escape completely. They lingered at the very edge, forming what we now believe is the Oort cloud. Chapter 3. Inner and outer Oort cloud. Scientists think the Oort cloud has two regions. The inner Oort cloud, also known as the Hills cloud, starts around 2,000 astronomical units. It's denser, but still incredibly sparse by Earth standards. The outer Oort cloud extends out to perhaps 100,000 astronomical units. It's more diffuse, but it's this region that sends us most of the long-period comets. The objects here are so far apart that if you were standing on one, you might not see another with the naked eye. Space out here is incredibly vast. Chapter 4. Is it still there? Now here's a question scientists still wrestle with. Is the Oort cloud actually there? Today? We can't see it directly, even with our most powerful telescopes. It's just too faint and too far away. But we can infer its presence from the behavior of comets. Every time a long-period comet appears, it gives us another clue, a whisper from the dark. And we have lots of those clues. For instance, the famous Comet Hale-Bopp, which lit up skies in 1997, is believed to have come from the Oort cloud. Its orbit takes over 2,500 years to complete, and it's not alone. Comets like C 2011 L4 Pan-STARRS and the more recent C 2020 F3 Neowise are likely visitors from this distant region too. So while we haven't seen the Oort cloud directly, we've definitely seen its messengers. Chapter 5. Visitors from afar. But the Oort cloud isn't just a source of outbound comets. It's also a gravitational front line. Because it's so loosely bound to the sun, it's vulnerable to the influence of passing stars, galactic tides, and even the motion of the Milky Way. Sometimes a nearby star or giant molecular cloud can pass within a few light years and disturb the orbits of Oort cloud objects. This can send a flurry of comets into the inner solar system. Some scientists even suspect that mass extinctions on Earth, like the one that wiped out the dinosaurs, could have been triggered by such an event, a comet shaken loose from the Oort cloud by a stellar encounter. So in a way, the Oort cloud connects us to the larger galaxy. It's where the sun's gravity ends and the galaxy begins to pull. Chapter 6. Could we ever visit? Now let's say we wanted to visit the Oort cloud. What would it take? The fastest spacecraft humans have ever launched, Voyager 1, is currently about 160 astronomical units from the sun, and it's been traveling for nearly 50 years. At its current speed, it won't even reach the inner Oort cloud for another 300 years. And the outer edge? Try 30,000 years. So, unless we invent dramatically faster propulsion, a mission to the Oort cloud is far beyond our current technology. But don't count us out. New missions are being dreamed up all the time. Some scientists have proposed ultra-fast probes using solar sails or nuclear propulsion to reach the Oort cloud or even go beyond it. One day humanity may finally touch this distant frontier. Chapter 7. Is it unique? Here's another question. Do other star systems have Oort clouds? The answer is probably yes. If planetary systems form the same way around other stars as they did here, then they should also have distant clouds of icy debris. Some exoplanetary systems even show signs of comet-like activity. We've observed dusty disks around young stars and seen comets transiting stars in data from missions like Kepler. These might be their own versions of Oort clouds. So in a cosmic sense, the Oort cloud may not just be part of our solar system's history. It might be part of what it means to be a planetary system at all. The edge of everything. The Oort cloud is the edge of the map, the Here Be Dragons zone of the solar system. It holds the oldest material, the quietest orbits, and the longest mysteries. It connects the story of how our solar system formed to the galactic forces that still shape it today. Even though it remains unseen, it may be the most important part of the solar system we've never visited. So the next time you look up and see a comet streak across the night sky, remember, it may have spent billions of years drifting in silence, alone in the dark, at the edge of everything, until now. If you enjoyed this journey to the Oort cloud, subscribe for more stories from the edge of space, the birth of worlds, and the future of exploration. Who knows where we'll go next?